Alright, I'm back. Let's talk more about stacks now. So we started here. We're now onto the stacks part, and apparently I cannot use my mouse. There we go. So we ended looking at the documentation for stacks. We poked around it quite a bit, and now I want to show you the first cool example using stacks. So here's our stack library. We have these operations that we can perform on a stack, not too many, and here is a cool example of reversing a list. So let's pretend we have our favorite list. Oops. I would like to draw, please. We have our favorite list, 1, 2, 3. And let's try and reverse that into 3, 2, 1 using a stack. So the algorithm is make your stack, starts out empty, and then visit every node. And in order, you'll push each element. Push 1 as you visit it, push 2 as you visit it, push 3 as you visit that. And then, oh wow, how convenient that the order in which I might pop these off is reversed. That's one thing that stacks can give to you. So we can just start popping this stack and make it a new list, pushing to the end of it. 3, pop and push to the end of the list, pop and push to the end of the list. And voila, we have reversed our list. So that's the beauty of stacks. That's one thing that it can do for us. So let's get that in code. So I'm in my lecture 12 folder I've made, and I'll make a file called reverse.cpp. Okay. So I'm going to first include the stack library, because I need that. And I guess I also am going to need the list library as well, because we need to start out with a list, don't we? We need to say, here's a list of ints. Let's start out as 1, 2, 3 in that order. And then I'm going to make a stack. I'll call it S, I guess. It's going to be a stack of ints, just like this is a list of ints. Call it S. I'm going to push everything onto the stack. So we can use our nice, we can use iterators, of course, or we could just use our fancy for loop, our for each loop. So that's fancier. That's easier too. So for every int I in my list L, please take that thing and push it onto the stack. Okay? So that's exactly what I was showing in code. Go through the list and just push everything onto the stack. And now, while the stack isn't empty, this is the process. While this stack is not empty, I want to pop something off of it. And that I will put onto a brand new list at the front, and it will have been reversed after I've done it. Alright, so while the stack isn't empty, pop stuff off and put it at the end of a list, of a separate list. So while it's not true that S is empty, we can use the .empty function to test whether or not our stack is empty. While that's not true, I want to get the top thing and push it onto a list. So I'll make a new list, L reversed, and it'll just be empty to begin with. And so this one will then, I'll take s.top and push that to the end of my L reversed list. Oops, sorry, L underscore reversed dot push back, and I want to push s.top on to the back of that list. Okay? And after I've done that, I've gotten the top thing off. Like I took the 3, for example. There we go. Took the 3 off. Now I want to get the 2, so I need to pop the stack as well. Okay? So there's that. And then we s.pop. And this will decrease the size of the stack, and eventually it will then become empty. Okay? So at this point, after the loop, we now have a reversed list. So we can iterate through that now for int I in L reversed. We can print it out and make sure it all worked out right. So print out I and a space maybe, and our new line. And that should essentially do it. So here is that, and it looks like I didn't save it properly. It still has a little plus sign. There it goes. -o reverse. And what do you know, using this stack to push everything in the list onto it and then pop it all off, we get it back in reverse order. How cool is that? That is one way you can use a stack and it's useful. Another way is you can use a stack to function as the back button on your web browser. So that's exactly what's happening when you press the back button on your web browser. Like here's your address bar, blah, blah, blah. Here's your back button. You click that, it has saved a stack of pages that you have been at. So like Google, Stack Overflow, blah, blah, blah. Maybe C++ docs. And the second you press the back button, it forgets about this one. Yeah, that's exactly what it's storing. It's storing a stack. Well, technically it's storing a deck, but we don't have to get into that just yet, because you can't go forward. So here I am. I can go back and look at my stack of all the places I can go. All of these places I have been, from an initial new tab to the first Google search to bring me here. See that? And pressing back will take me there. All right, and I popped off the stack, and now if I press back again, I don't go to the same place. I go to one further place. I go down the stack. Yeah? So pressing back pops. Isn't that cool? So maybe we can just quickly implement that. And then the rest of this is going to be your review. So for your midterm. Dun dun dun. Let's make a stack. A stack of strings for like web pages. So call it back button. So the very first thing we do, the very first page that we go to, for example, is we make a new tab and we go to Google. So back button dot push Google, or I don't know, google.com, and then we search for something C++ related, like C++ stack, and then that's our second page. And that's like google.com / something, I don't know, / search, who knows. Blah, 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 dot, dot, dot. That's our second page on our stack, and if we were to press the back button, we would pop our stack and go back to Google. And then maybe from there we go to, I don't know, push C++ docs. And maybe that wasn't helpful enough. So, dead end. Let's go back to the search page. And so when you press the back button, you pop the stack. And then you go back to the top of the stack, which is now going to be your Google search again. And maybe from there, you click Stack Overflow. And that gives you the answer that you need, and then you can close the tab. Okay, so that's essentially your back button in a nutshell. It's like, first you're here, then you go somewhere. So this is my current top of the stack, just Google. Why won't it go away? I want to, yeah. So first we push Google. Now we're on Google's web page. Now we search in their bar for C++ stuff. And then we have a search page that shows all of our search and all of the results. And then maybe from there we go to the C++ docs with its little sidebar. And then we don't like being there, so we pop. All right, and then we go back to our search page, which is our new top. And from there, maybe we go to Stack Overflow instead. So instead of here, we go to Stack Overflow. And then we have all the answers and some ads on the side. So, and then if we were to press back 3 times, or twice I guess, we'd pop this stack, go back to the search page. We press back 1 more time. We go back to Google. So your back button on your web browser is storing a stack, and it really is useful because the top of your stack is where you currently are. So it's the top. That's the top, that's the top, that's the top. We pop it, and now the search page is at the top again. Then we go to Stack Overflow, that's our new top. Okay? So let's press the back button as much as we can now. Our current web page is the top, of course. And we press the back button. And that will take us somewhere new, potentially. S dot, no, sorry, it's called back button. It's not S anymore. Back button dot pop. Okay. And we can go and run this program. Oh no, I spelled it wrong. There we go. So, at the very end, we were on Stack Overflow, we pressed the back button, then we got back to our search page, pressed the back button again, we got back to our original google.com page, and pressed the back button 1 more time, and we're back to a new tab. There's nothing left. Okay. So that is stacks in a nutshell, and you are now experts. So that's the end of the main slides. We're going to get into the midterm review, and I think I'll make a new video for that. So here are some exercises for you that will help you ingrain this stuff in your mind. So here are some weird ways to implement a stack. You can totally represent stacks with things other than lists. So try these. See if you can figure out how you might do it. Store the stack contents in one long string. Can you do that? How would you encode/decode the data that lives inside the stack? Alternatively, you could store the stack contents in a gigantic number, assuming that you had the capability of making numbers of arbitrary sizes. Be like 100. You could have as many digits as you wanted in your numbers, which is not the case for C++ at the moment, but there are like large integer libraries where you can make numbers as big as you want them to be. So it's possible to store a stack as a just large gigantic number. How might you do that? And then finally, how can you store a stack using a vector? What operations can you use on vectors to model stacks? And that shouldn't be too bad. So think about that. And then possibly hard mode, you'll have to think about it. Take your vec class from lab and make it a templated version, because it's just a vec. It holds an array. Like, here's our vec v. What's stopping us from making a vec of strings or something? Or a vec of doubles? A vec of chars? It's just something with a size, instead of num items. The capacity I'll call cap. I don't know, 4, 2, and an array. And we don't really care much about what's in the array as long as we can get there. So why can't this be A, B, C, D? The array is just an array of chars in our case. Make this generic. Make it work for any class T. Okay? That would be a great exercise for you. Good practice for the future labs. And yeah, that's where I want to leave us there for the normal part of our slides. I'm going to, I think, make a new video for the midterm review, and I'll see you in that one.